Okay. My name is S. Chandrashekar. I used to work in the Indian Space Research Organization during the period 1993 to, sorry, 1974 to 1997. Uh, I joined the space program after graduating with an engineering degree from IIT Madras in 1972. And then I did a couple of years of management or an MBA program at the Indian Institute of Management, Calcutta. And I joined ISRO and Professor Dhawan's group called the Systems Programming and Analysis Group at ISRO headquarters, I think in June 1974. I left ISRO around September 1993 and went on to a faculty position at the Indian Institute of Management, Bangalore. And of course, I've been involved directly or indirectly with all kinds of space activities even after my leaving ISRO. So this is about some of the things that occurred to me during my tenure at the space program, in the space program. I thought some of the things that we experienced at that time would be worthwhile for many of the people who don't know anything about the earlier days of what we did in ISRO to become aware of the kinds of challenges and problems that we faced at that time. And the kind of people and the way in which ISRO was organized and the leadership that it provided to a whole host of other entities was something that needs to be kind of aired and become more prominent and well known. So let me try to give you a flavor of the kinds of things that happened to me during my tenure at ISRO. I will only talk about the things that I remember very vividly as important. There's a whole lot of other things that have to be studied and understood in greater detail. And it's worth a major, what I would call a narrative, or a historical narrative, if you want, of what happened and the events and the people involved and what kinds of things made ISRO what it was at that time and what it is today. So I will try and give you a few of the personal things that I experienced at that time, which kind of stand out even now after so many years. Now, one of the most important things that I remember as a major moment of elation for all of us who worked at ISRO at that time was the launch of the SLV-3. The first launch of the SLV-3 took place around 1980 or 1981. I don't remember the exact date. But I do remember it was a time of jubilation and celebration of success. There is a small film that was made at that time by the Films Division of India. I think it is worth looking at that film because that film captures something that many of us may not even be aware of today. It showed the kind of joy and the kind of unanimity of this great achievement that we thought we had achieved at that time. And it kind of symbolized the fact that ISRO at that time believed that after the launch of SLV-3, we could do practically anything in the world. And technology was not a constraint, money was not a constraint. So it was like, the whole world and the whole opportunity space was there for us to take. It was a moment of jubilation and joy for all of us. It was a fantastic event. But let's not forget that before this event happened, the first launch of the SLV-3, which happened, I think, in 1979, actually failed. And what I remember about that failure, and again, I cannot forget the greatness of my boss, Professor Dhawan, who actually did something that amazed me at that time. He actually, after the failure, he actually took responsibility for the failure. And I remember he made a statement as something that he said is we did not fail. He said something like we were partially unsuccessful. And, that statement created a lot of controversy in the press. Even today, you can see some of the controversy regarding space activities that comes out in the newspapers and affects everybody else. But what I remember most vividly about that particular moment was that Professor Dhawan actually took responsibility. And not only did he take the responsibility, he also wrote a letter of resignation and sent it to the Prime Minister to say, he said, I take complete responsibility for what happened. And he did tender his resignation at that time. I happen to be aware, many people may not be aware of this particular event, but I was there at that time, and it definitely happened. And in contrast, when SLV3 actually succeeded in 1981, Professor Dhawan did not come and talk about it himself. He made sure that Dr. Kalam, who was responsible for the SLV3 architecture at that time, actually made all the public statements. So in a sense, it showed, it kind of, I remember this very vividly, because Professor Dhawan was this great inspiration for a lot of us at that time. Not only was he an inspiration in talking, he was also an inspiration in the way he did things. And I believe that was one of the most important parts in my life. And his impact on what I do and how I do it is still there after so many years, even though he is not around anymore. The second incident that I would like to talk about is a little bit more personal, I would argue. See, one of the things we set up in ISRO in the early days was a number of study groups that tried to look at what the future was. And it so happened that after joining, I became involved in the remote sensing program of India. I and another couple of colleagues, Rajan, Sudarshan too, to some extent, were important components of some of these things. And Professor Dhawan set up this study group for looking at remote sensing satellites. And I was the member secretary of that study group, and we actually produced a report, which in a sense set the kind of trend for the IRS. So I had what I call the beginnings of the remote sensing satellite program. I was involved in it. And I think the satellite got launched in 1988. Okay. So that 12-year period, I saw the satellite from conception through the phases of initial technological components being developed across the board. And then I saw it actually being made. I was involved in a lot of the activities associated with its making. I was involved in the mission planning and all that went with the mission planning of it. And finally, when it was launched, I actually saw this cycle from conception all the way to realization, orbit delivery. And then when I saw the first picture that it showed, I think it was a picture of the coast of Tamil Nadu. And it was like one of those really fulfilling moments in my life. And of course, you feel very high and you think that, yeah, we have achieved this and there is nothing that we cannot achieve. It was a fantastic. The fact about IRS was, the other thing that made you very proud about IRS was, ISRO actually came up with this choice of the sensor complement on IRS was based upon a technology called charge-coupled device technology. And it was fundamentally different from the major technology which NASA had pioneered, called the multispectral scanner technology. And I remember the study group with which I was associated. One of my colleagues from the Space Application Center, I don't know whether people know him, Dr. George Joseph and his group, the sensor development group there. They actually came up with the idea that the NASA technology had kind of reached its limit and it was no longer capable of growing, no longer capable of becoming, you need a higher resolution capability as we go forward. And India had this peculiar problem of small field sizes. And therefore, high resolution requirement was important. So I remember a presentation that Dr. George Joseph made to our group, which actually said that the current technology, or the one that we were trying to follow, had reached its limit and that we should look at the new technology. Somehow the study group was able to understand the implications, and we actually pushed a lot of it. I mean, we have documented this, so I will make that report available so that you people can. We actually documented how it happened, the people involved, the processes. It's more like how innovation happened in ISRO at that time. It's a report that I can make available to all of you. And, it actually moved. I think ISRO was one of the earliest countries in the world to embrace this technology. And I think the French and we were almost parallel or almost simultaneous in our choice of this sensor for the payload of IRS. And what happened is, as a consequence, the path to high resolution and addressing genuine problems of Indian agriculture opened up. And I think after I left ISRO in 93, 95 or so, IRS-1C was launched. And IRS-1C, when it was launched for a certain period, I think had the distinction that it was the satellite with the highest civilian remote sensing resolution in the world. I think maybe for a period of 5 or 6 years. And I think that choice still enables ISRO to kind of take a leadership role in the remote sensing satellites of the world. And I believe that, so my involvement and support and all that happened as a part of that is a truly remarkable experience for a person like me. And I have to say that a group of us who understood this and, kind of did it, and it's all documented. And of course, one cannot rule out the role of Professor Dhawan and my other colleague Rajan, who was involved in it, and a lot of my colleagues from, right. This was something that I thought I should share with a larger audience. So this was one thing that I would like to add. The third thing, I don't know whether to call it third or fourth. See, one of the early satellites, remote sensing satellites that we employed was called Bhaskara, which had a very poor 1 kilometer resolution. It was a kind of building block for IRS at that time. And it had this television camera payload to take pictures of the Earth's surface. When it was launched, the cameras were switched on, but there is a high voltage section in TV, right? And you kind of do some technological potting or to make sure that. So there was some problem, and the high voltage section created a kind of spark that prevented the cameras from getting switched on. So we decided to put off the cameras and use the other payload, which was a microwave radiometer, in order to be able to do something with it. And then our analysis and all our experts had done a lot of simulation, and they felt that because of the gases that were responsible for the sparking, if we allowed time, the gases would diffuse out because of the vacuum in space, and maybe after some time we would be able to switch the camera on. So the proposal was that after about a year of working of Bhaskara 1, we would try to switch the camera on again. Now we had a meeting in, I think in the satellite center, and I think Professor Dhawan was there and all of us were there. And there was this debate about whether we should or should not do it. Now there was a view that if you put it on and the satellite had a problem, we would lose the satellite. And there was the other view that we should take the risk because anyway most of the mission things had been done. And if you get the image, actually the objectives would be realized. So there was this huge debate within ISRO. And at the end of it, we decided that we would go ahead with that. I have a colleague of mine in the satellite center called P.S. Goyal, who was very sure that the camera would work. And Professor Dhawan, who was also there, said, while he was for the thing, he also said that he actually said something like, we'll take a bet, I can be sure and all that. So I think there was this bet between Professor Dhawan and him, and I think the bet was for ₹1 rupee. And Professor Dhawan said that if it really works, I will give you ₹1. And so I think finally when we did switch it on, the camera did work, and we did take a lot of pictures, and we were all very proud of it and all that. And I think Professor Dhawan gave a ₹1 note to Goyal, signed by him and all that. I don't know whether he still has it, but I still remember that very vividly as one of the a kind of way in which ISRO looked at all these problems and the camaraderie and the kind of give and take that happens between a very high level and, I don't know, not so high system and of management within the system. So this was something that, still comes to, still comes to me. The fourth or the other thing I would like to talk about is some of the notions that organizations have about how easy or how difficult it is to build on technology that we have achieved and to kind of, improve it. Now, I remember that after we did SLV, the question is, or even before we did SLV, Professor Dhawan had already started the work about trying to do what had to be done. Of course, one requirement was the PSLV. I'll talk a little bit later about the PSLV, but I thought it's useful to mention that we also came up with this idea of what I call, the augmented satellite launch vehicle, or the ASLV as we used to call it. And the idea was that, SLV had 4 stages. So you would add 2 equivalent first stages to the first stage. So you had a kind of strap-on boosters to the first stage. And you would then go from a 40 kilogram payload to a 150 kilogram payload. And because of that, you would, you could do significantly more things in space. We debated this extensively, and I think finally the organization decided that we would go with it. I think the first launch happened after Professor Dhawan had left. He had quit as chairman. And we realized the rocket took off, okay. And just as the two booster stages were going to separate, right, about 50 seconds into the flight, it failed, okay. So there was the usual failure analysis and all that, and a lot of people said there's some fail-safe device that prevents the satellite from exploding on the launch pad. Maybe we should take it out and all this. So this was like a top-down led investigation of the failure, and many people at the top felt that this was the reason for the failure, and maybe that's why the failure happened. So they fixed that, and we did the second launch of ASLV. And if you look at the second launch of ASLV, it failed almost exactly at the same time. Again at the separation of the of the booster from the first stage. And so there was this, so there was a lot of introspection and debate within ISRO about why. And since the two failures are very similar, maybe there's an underlying reason that we didn't understand what was the reason. And so we had this time an investigation committee from outside. It was led by Professor Narasimha, who's also a student of Professor Dhawan and a member of the Space Commission maybe at that time. And that investigation came up with a very detailed assessment of what the failure was. So it came out that adding those two strap-ons was just not an incremental change on SLV, but a fundamental, radical change in the architecture. So the way changes in complicated linkages of technology, which is called architectural changes, kind of impact performance, was something that we all assumed that by doing it, it's easy to do. We all wanted it to be easy, right? In a sense, so you can argue that it's an organization belief that what we were doing was logical, understandable, but technology is not like that, right? When you add those two strap-on boosters, it's not an incremental change to the vehicle, but a fundamental alteration in the vehicle parameters. So this was a lesson that was bitterly learned by ISRO. But I think the greatness of ISRO was that not only did it learn this lesson well, it also assimilated this, and we brought a lot of this into the PSLV design. And as you can see, the PSLV design is a robust design based upon this kind of learning. And therefore, the ASLV, in my opinion, even though we didn't continue with it as a major project, was a learning platform for a lot of things that actually happened on PSLV. So this is like, what you need to do internally in order to learn the right lessons and to kind of improve upon it, and therefore to go forward. So I would argue that this was another main thing that was characteristic of ISRO of that time. It was a learning organization. It learned from failures, and it kind of built on that learning. So I think that was one thing that I would like to kind of emphasize. So let's get on to PSLV. Okay, I mean, my point would be that the PSLV possibly represents one of the most successful launchers, not only built by India, but it would stand on par with almost any launcher built anywhere in the world. And when it was configured, okay, it was a very odd combination, right? We had the solid rocket, and then we had a liquid stage, then we had another solid stage, and the original design had a fourth solid stage. And then finally, I think due to differences and the way we had to inject something into orbit, it was replaced with a liquid stage. And in my opinion, that configuration was odd. Many rockets were liquid rockets. Nobody had a solid rocket. And it was an architecture that was indigenously done. And a lot of people used to make all kinds of comments, okay, including whether it would fly at all or not. So I would argue that it was an architecture. It largely came from within ISRO. And a lot of it had to do with Professor Dhawan's understanding of it, and maybe all the technical capability of our Trivandrum Center, VSSC, which is, in my opinion, the heart of ISRO's technology. And so it was one of those, architectures that, and it had several very original kind of approaches, and it had a lot of indigenous technology that had been pushed earlier, but it kind of saw fruition in it. I'd just like to talk to you about a few of them. So one was this architecture, which everybody said was not going to necessarily be questioned whether it would work or not. The other thing that it had this control system that was, I think, very unique in the world. And that uniqueness largely came about because of the constraints that ISRO faced. One of the constraints that ISRO faced was the fact that we did not get the required microprocessor capability because they all came under export embargoes. I think by the time PSLV had come, MTCR was in force. And the microprocessors are the heart of our control systems. So computing capabilities is key to that. And so therefore, we had to do with conventional microprocessors. And conventional microprocessors, not what I call space quality, right? So we had to take regular microprocessors, screen them, put them through some kind of environmental testing, and finally use them. So PSLV had this unique control architecture where there were 4 microprocessors that were working in parallel. Okay, and if one failed, the other 3 could do the job. If 2 failed, the other 2 could do it, and they were cross-strapped in such a way, right, that effectively, I mean, unless all of them failed, effectively the mission would be successful. Now I remember that we had these. So Professor Dhawan and maybe Professor Dhawan wanted a review of whether of all that. So we got a couple of experts from NASA, some people from ESA. European Space Agency, the National Aeronautics and Space Administration. And they came and they looked at it and they were actually shocked. They said, nowhere in the world, right, have you seen such an architecture. He said, most of our vehicles use 1 microprocessor, right, for the control logic. So let's not forget, a launcher is not going to last, it's not going to do a function for a very long time. It's going to take a short time. It has to work reliably only for a very short time. So the problems of reliability are kind of different for. But, so they were amazed at this. And I would argue that the PSLV therefore represented a very, and the software, very complicated software and logic. But I must say that our greatness in VSSC was the fact that it has worked. It has worked so well. And I think PSLV, as I said, has been one of the most successful launchers anywhere in the world. And therefore, so the point I'm making is indigenous capability, indigenous design, robustness is kind of very, very important part. Now, PSLV has other great things that I think is worth. It represented a lot of indigenous capability. One of the choices that ISRO had to make was about choice of propellant. The standard propellant that SLV used was something called polybuta acrylonitrile. Sudarshan would be in a better position to talk in greater detail, but let me give you the gist of what I know. So the ISRO people felt that it was antiquated, a little old-fashioned, and that we should push the latest in terms of the technology requirement that is needed. And that was something called hydroxyl terminated polybutadiene. I remember a meeting in ISRO headquarters where this was debated. And finally, ISRO didn't have any understanding of it. It didn't have any capability also. It was a kind of lab-scale demonstration. And we took the risk and said, we will go with that. So hydroxy-terminated polybutadiene without a lot of backing, just like the CCD decision, right? We took that decision and we went with it and we developed it, we transferred it to industry, it went into production, and then it went into the rocket, and it's performed very successfully. So this was one other choice. The third thing that I think you should talk about a little bit was, we had these. The critical part of a rocket is going to be the guidance system, and gyros are very important for that. ISRO had invested a lot of money in something called floated gyros. They use a lubricant, a liquid lubricant, in order to. Gyros have to spin at very high speeds, so they need to be lubricated. Okay, and they used liquid floated gyros as the main requirement for it. A couple of people, one of the major innovation groups in VSSC was a group headed by Mr. Vedachalam, right, who actually, in a sense, was one of the innovation pioneers. Many people may not know about his contribution, but I thought I should tell you something about that and so he and his group, I think a couple of engineers in his group, came up with this notion that the alternative technology, which was kind of emerging, was something called dry tune gyros, which did not involve liquid lubricants, but a kind of dry approach to doing it. I don't want to go into the technical details, but it was kind of a new technology that is evolving, right? So the question is whether we should stick with the old technology and the investments we've made or go with the new technology. I remember a huge meeting again in maybe VSSC, right? And we finally again decided to go with this dry tune. And dry tune gyros flew not only in PSLV, they also flew in IRS, which also requires gyros. And therefore, it represented a major leapfrogging in a very critical area. Guidance and control is possibly the heart of any launcher or satellite. And that was one. And Vedachalam's group also pioneered what I call the solar array drives. One of the requirements for a satellite is that the solar panels have to get deployed, and the panels have to rotate in sequence with capturing the maximum, light from the sun. So they rotate along with the orbit. Okay, and therefore they need to be continuously working for a satellite mission. Those arrays were also developed by the same group, right? And they did also these momentum wheels that are required for satellites, which kind of provide the heart of the control system. So all these things were done by this group at Trivandrum. And I think Apple, IRS, and or PSLV were all kind of common elements that benefited from this. So therefore, and I think finally, which I think I should also talk about it, one of the other requirements is the structural part, the part that has to do with the. So ISRO used a French steel called 15 CDV6 in the SLV3. And the question is whether we should continue to use them or replace them, right? I think Sudarshan, my colleague here, actually talked about maraging steel, which is the alternative, which was state of the art at that time. And all of us at that time felt that it was the way to go. And there was this debate, 15 CDV6, we had investments, we had, mastered everything, whether we should go with maraging steel. Maraging steel involved a lot of problems because you had to go to get it fabricated. A lot of heat treatment was involved. So we had to tie up with DMRL and a whole lot of other entities. Sudarshan actually did a lot of that work. And finally, we did go with maraging steel. And again, it represented, in my opinion, a major push in the technology side. So I would argue that Apple, IRS, and PSLV gave us this major head start in key areas of technology. And most of these technology developments came about because of Dhawan's insistence that we create a lot of internal study groups that kind of weld link the silos of, structure, control, different domains of knowledge into something that actually makes sense for a program. So the projectization, the programmization, and the kind of cross links that we actually created this hybrid organization. So it was a combination of a formal vertical structure and an informal kind of networking that created what I would call a very innovative organization. So PSLV, IRS, and Apple therefore represent a kind of major intermediate steps, and they were all creations of Professor Dhawan. Okay, and so that was something that I thought I should talk about. Okay. Now, what else can I say? Yeah, I think one should also look at Insat a little bit because I was maybe not directly involved in all of it, but peripherally involved maybe a little bit, and some parts of it more directly involved. Okay. So when Professor Dhawan took over in the early 70s, there was a major problem. Sarabhai had come up with this notion of Insat. Okay. And everybody knew that a communication satellite in geostationary orbit and the ability to reach it. So GSLV and Insat were the kind of goals that ISRO wanted to kind of get at. And therefore, we needed to be able to build, right, communication satellites that would serve Indian needs. This was a major challenge for us at that time. I think Sarabhai, if he had continued to be alive, might have made it happen. But when Professor Dhawan took over, things were not that good. Now, I have actually seen a letter, right? I mean, during my time in ISRO, I've actually seen a letter from the Secretary, Ministry of Communications. I don't know whether it was to Vikram Sarabhai or to Professor Dhawan. I don't remember very clearly who it was. But that letter very clearly stated that the Ministry of Communications and the Department of Communications did not see any merit in launching a communication satellite for India. In other words, there was no user interest in communication satellites. So Professor Dhawan had a major problem. How do we go about trying to resolve that problem? I think this is where I think Professor Dhawan's mastery of strategy and understanding of politics is kind of important. I thought I would therefore talk about it. So he had to get a base of users to agree, because Insat required money and it also required support. And he could not go to the government without guaranteeing that the user ministries actually did not say it should not be required. Okay, I mean, they actually at least should say be neutral or also support it. Ideally, he wanted them to support it. So we were going through this debate of how do we do that, okay, and how do we garner support. So one of the things that we came up with was that we would do a lot of experiments. So Professor Dhawan came up with this experiments, communication satellite experiments, where we got hold of a European Space Agency's Symphony satellite. And they gave us the satellite on loan, and we demonstrated a lot of ground-based communications experiments with Symphony. That was a kind of intermediate application kind of focus. Then we had this opportunity to launch Apple, right? There was a development flight of the Ariane, and the European Space Agency wanted some country to take the risk. It might fail, to take the risk and put a satellite. And they would give us the launch free. Of course, we didn't have to pay for it. In those days, we didn't have the money to pay for it, maybe. So this opportunity was available, and ISRO saw that opportunity, and Professor Dhawan, in a sense, saw that opportunity. And we decided that we would bid for that. And the Apple satellite came directly out of that opportunity space. And we pushed it. In a 2-year development, we actually made it work. I'll talk a little bit about Apple a little bit later, about one of the things that happened. But that was some. So we had this nucleus of sorts being created in parallel. And therefore, we needed a way in which Insat could be progressed. Because after Apple, we had to go to Insat. Clearly, that was what was needed. So Professor Dhawan then came up with this fantastic possibility that apart from the communication requirement, we could also add what is called a very high resolution radiometer, which actually takes a picture of the weather patterns in the country. And you know that cyclones are major problems for India. And one cyclone can create so much damage. And if you can at least prevent or warn against a cyclone, you can actually save a lot of lives. So here you had an application possibility that, if it could be combined with the communication possibility, can actually justify the cost of building an Insat, and maybe the benefits are likely to exceed the costs, right? This was a calculus that I think Professor Dhawan had made, and we did a lot of work in order to kind of back it up and support it to do that. And therefore, the idea of bringing in a kind of weather payload or a weather camera, to put it very crudely, into the Insat program was largely a political decision in order to justify the program and to make sure that the government supported the program. So this was a master political move. But it had a number of consequences, which I think I must also talk a little bit about so that you understand the totality. Now, at that time in the world, there was only one satellite that I remember had a combination of a communication payload and the weather payload. And that was the ATS-6 satellite, which had been used for the site experiments. It had been moved to a location over India or near India, and we used it for the satellite instruction television experiment that Sarabhai had kind of come up with, and that happened during Professor Dhawan's time. So it was to show that education can be reach the villages of the country through space. Okay, that was the kind of message that was done that. So no other satellite had ever had this combination. Okay, and it had a lot of what I call architecture. The satellite architecture will therefore get affected by this combination. So we did a lot of work, and we came to the conclusion that in spite of all the complications, the satellite was doable. So one of the requirements for the Insat specification was that we would have not only a communication payload and a TV broadcast. Both are what I call electronic transponder-based things. And in combination, we will have an imaging instrument for the weather, right? So IMD, Ministry of Communications, and Doordarshan or Information and Broadcasting became our three major users for the Insat program. Now, this had a consequence because when the satellite was designed, the VHRR instrument cannot directly look at the sun. Okay, it has a problem. So because the infrared detectors, if they see the sun, will stop functioning. Okay. So they had to make sure that the satellite orientation was such that it would never look at the sun. So if you have solar panels deployed on either side, the solar panel reflection would affect directly the imaging instrument and all that. So they had to move the panel, huge panel, because Insat required a lot of panel, to one side. So the moment they moved it to one side, there's a question of stability of the satellite, right? So in order to provide that stability, they had to deploy a very long boom on the other side. So that was the architecture that came up. Now, Insat 1A was launched. The boom, the Insat 1A was bought from Ford Aerospace because we couldn't build it in time. And, so they came up with this design, great design, very well conceptualized. But unfortunately, the boom did not deploy. Okay. So one of the consequences was that the boom did not deploy, and Insat 1 effectively didn't, last very long. I mean, it kind of. So there was this, churn again and all that. But ISRO stuck to this logic that it was a technically correct solution, and the subsequent Insat satellites actually worked. And many Insat 2 satellites, which were built in India, also followed. And in almost all cases, I think in all cases, the deployment of the boom and all that did work very well. So this fundamental choice is no longer an issue. I think because of developments and the increased need for communications, the two payloads may now be separated. But in principle, ISRO could still build these satellites and either separate them or do them together. Both options are available. So this is another question about how the political part of what we are talking about can actually have technological consequences and actually create an impetus to be different, and I would argue a little bit original. So once again, you can see that kind of thing happening in Insat. Okay, so this was the other thing that I thought I should talk to you. And so what else can I talk about? Okay, let me talk a little bit about something to do with geopolitics. Okay, since I was directly involved in a lot of it, a couple of things stick out in my mind, which I think I must at least talk about. One of the things that I remember was the India signing the 4 space treaties. Okay. Now, when I joined ISRO, Professor Dhawan had already thought about signing. Okay. So there are 4 treaties on space. The mother treaty is something called the Outer Space Treaty, which lays the basic foundation stone. And then there is a liability convention, which says that if somebody launches a rocket and that rocket lands somewhere, or if some satellite re-enters and it enters over it can cause damage. And how do you address the issue of damage? Okay, so that was the other treaty. Then astronauts go into space at that time, right? What happens if an astronaut lands in some other country, etc., and all that? What do what kind of legal arrangement that you should and all that? And then the 4th one was what is called the Registration Convention, which means every satellite that is launched into orbit, you have to provide details to the international community. Orbit, perigee, apogee, what kind of payload, where is it launched from? And there's an international numbering sequence that gives you all that number. All right? So these were the 4 treaties. Now, I think India had signed all of them, but signing in the UN parlance is not the same as ratification. You need to accede to the treaty formally. And we had never acceded. Okay. So going back to 67, we have never acceded to any of the treaties. So when I joined ISRO, I was working with Professor Dhawan on trying to get, Indian ratification, because Professor Dhawan believed that since we took a lot of help from international organizations, Bhaskara one, Aryabhatta, right, SITE, we also needed to show that we are responsible citizens in the space world. And he felt that signing that would indicate that India is a responsible space power. And we put a lot of effort into it, right? I think I must have had about 4 or 5 huge files of correspondence. So the Ministry of Defense had some concerns about internal security. Our external affairs had some concerns about something else, right? So there's a huge, government bureaucracy is a huge problem, right? So from 74 when I joined till about 78 or 79, this thing was going on, and every time Professor Dhawan went to Delhi, he would go and meet the cabinet secretary or go and meet the defense secretary and try to get them to understand what was the reason. But it got tangled in this huge mess of bureaucratic red tapeism and all kinds of things. So nothing happened. What happened is there was this American space laboratory called Skylab. That's, it had a problem initially. One of the panels didn't work and all that. So it got into a problem right from the start. But they were able to operate it. It's like a space station, not like a lab. It's more like a space station. So what happened is it kind of started decaying. They lost, they didn't have enough propellant to control it. It started decaying. And there was a likelihood that it would re-enter the Earth. It's a huge satellite, 80 tons or something like that. And when it disintegrates in the atmosphere, large pieces are likely to land. Fortunately or unfortunately for ISRO, one of the areas over which it landed was the Indian Ocean and India. Those are. So NASA had said there's a high probability that this would land over India. And I was in Delhi with Professor Dhawan, and we were having a meeting about, we were having a preparation meeting for this United Nations conference that was scheduled for 1982, I think. So we were having some, or I don't remember, maybe we were having a meeting in Delhi when suddenly this issue came up, And the question then was if it lands in India, does India have any legal recourse to being able to handle that problem? Overnight, what we had been working on became a high priority issue, right? And I remember there was this joint secretary in the Ministry of External Affairs, a person called K.P. Jain, So we were wondering what to do. And now, Professor, we were saying, we've been trying, all this stuff. So he took on himself the responsibility to do it. So we had to do it just before, Skylab really re-entered. So we didn't have that much time. I don't remember the dates, but maybe you can check it out and see. But I do remember we didn't have a lot of time. Okay. And at that time, then, he said we will push it and all that. So he took upon himself the responsibility. And he managed to get the government paperwork done to make sure that we acceded to the treaty, I think 2 days or 3 days before the re-entry of Skylab. So my point is, you spend a lot of time doing the obvious, but it takes a crisis in order to finally. And I think there was some weird comment. They said in order not to make it appear, this was the comment, in order to make it appear that we are not doing it because of the re-entry of Skylab, we will sign two, the Liability Convention and the Astronaut Convention maybe first. And then after some time, we will sign the other two treaties. I think finally, so we signed these two treaties just a couple of days or 2 or 3 days before the entry of Skylab. And the other two treaties we signed again together a little later. And there's the other treaty that was being negotiated called the Moon Treaty, about how the resources of the moon are to be used and all that. So we signed that again, maybe together with the other two treaties. So this was the other thing that you kind of see happening. So the other thing on the geopolitical thing was, I must tell you a little bit about the launch services agreement that we had with the Soviet Union for IRS. I'm sorry I do a lot on IRS because I'm more intimately involved with that. There are, of course, many other things that one can talk about. But so we had this, so we had to launch IRS. And the Soviet Union was an obvious candidate because, in my opinion, they'd done the Bhaskara launches. And Professor Dhawan wanted it to be a commercial launch. He said, we don't want this free bit. We should do a commercial launch. So we had a committee, 3 of us. I think Dr. Kasturi Rangan, who was the project director for IRS at that time, Mr. Seshan, who was our additional secretary or joint secretary at that time, and we were the 3 members of the committee. And so Professor Dhawan insisted, we need to compare. So we looked at Thor Delta, we looked at Ariane, a whole lot of other launches. And we came up with this possibility that we should look at the Soviet launch. And we came up with the justification for the Soviet launch, right? Now, one of the issues that came up during that time was whether we should launch liability, this bit I was talking about, whether we should take insurance. Now, Insat had preceded a lot of those negotiations. Now, the Americans always insist that liability for launch, right, should not be with them, right? So they have a limit. All liabilities less than $500 million will be covered by, you need to go to an insurance company and take insurance so that if there is a liability claim, the insurance company will pay. NASA will be liable only, or US will be liable only, because all countries, not NASA, US will be liable only if it exceeds 500 million, something like that they had. And we had negotiated Insat. And so, the standard ISRO practice is we go to Lloyd's in London and take an insurance. I think it was about $100,000, $200,000 in those. It's quite a lot of money. Okay. We were not exactly floating in money in those days, so it was quite a lot of money. So when we were doing this, Mr. Session and all had been involved in those kinds of negotiations. Now, I had been only peripherally involved in that, but I understood Russia, Soviet Union quite well. And I know that they are strict interpreters of the legal part. So we had this internal debate about how do we do it. According to the Liability Convention, all it says is that we should get into an agreement with the launching state about liability. It doesn't say, you should do insurance or anything. That was a practice that NASA had followed. So I was saying that we should talk to them and ask them what happens if there is a failure, right? Rather than going and saying we'll take insurance and do that, right? So we had this huge debate and all. Professor Dhawan said there's no harm finally in trying it and we should go and try that. I remember we went and explored this possibility, and I think the Russians only said, Soviets only said this. They said, we will be responsible for the launch. If the launch fails, we'll give you another launch free. Okay, that was what they said at that time. So this was something that also was, I thought, I would say, we were willing to go and try it out, and it's not as though hierarchy and knowledge had some value, let me put it that way. Of course, Mr. Session was was a fantastic person also in his own way. So whatever Professor Dhawan said, he would finally do, whatever it took. I'll talk a little bit about him later. So the point that you're really making is that this was something that I will remember, because we did save, I don't know, $200,000, not a lot of money, but it was something that I felt proud about. The other thing about the launch was the price. Okay, we had, so I remember we negotiated with them, and Mr. Session's a hard negotiator. And so the Soviets were very, very nice, okay, absolutely generous. They said, so we brought the price down to 7.5 crores for if you compare it, a Thor Delta would have cost us about 35 crores. Ariane might have cost about 35 crores. So we were really about 4 times or 5 times cheaper than the international thing. So I think we went and met Professor Dhawan, and I think all of us, and Kasturi Rangan, myself, and Mr. Session, we all agreed that they could possibly bring down the price, okay, further if we negotiate harder. Professor Dhawan told us that I don't want any more negotiation. He said 7.5 crore is a steal. We will stick with that. I don't want any more things to be negotiated. We definitely need to make sure that we honor what the Soviets have given us. Okay, so that was his take on it. So this happened, and we agreed on that price. And then finally, the contract had to be signed in Moscow. Okay, so Professor Dhawan and I think Dr. Rangan and my colleague Rajan, I didn't go to Moscow, so this is second hand, so I don't know. But this is what they used to tell me. So we went to, so the final thing was being signed in Moscow. At that time, the Indian ambassador to Moscow was Ambassador Ahuja. Okay. And I thought he was, I have not met him, but according to all the people who were there, he's very much like a Russian. So he said this price is too high, right? And we must reduce it even further. Professor Dhawan was not very comfortable with it. I'm sure he was not. I mean, although I was not there, I would assume that he was not. And so apparently the minister and Ambassador Ahuja went into I don't know whether vodka was drunk. This is the story I've heard. Some toasts were exchanged, and the price came down from 7.5 crores to 4.5, some number like that. Okay. And so that is something that we all, all the people who are insiders, we kind of used to talk about it. I don't know whether anybody still remembers it, but I thought it's something that you should know. So it was a very, what I would call again, a very informal, informal combination that made ISRO what it was. Okay. So that is one thing that I thought I should talk about. What are the other things I can talk about? I can talk about some of the people. I think ISRO was at that time gifted, I would argue, with some of the most capable people in the country. We were actually, I think, an organization that had the best technical talent, right? As I said, VSSC is a fantastic technology organization. ISAC is very good. Space Application Center, where a lot of things happened, is also very good. A launch complex in Sriharikota was staffed with a lot of engineers of all kinds. I talked about Vedachalam, George Joseph. Many of our engineers are fantastic. They are very good. But I must talk a little bit about some of the other people. I talked about Vedachalam, talked about Sudarshan. I had this colleague, Rajan, who was my boss, immediate boss in ISRO. He kind of integrated all components of the program. He was scientific secretary, the second scientific secretary in ISRO. In my opinion, he actually created the job. He actually grew and created the job. He worked very closely with Professor Dhawan. And he was a kind of linking pin amongst all the programs. Okay, and he provided this combination of what I would call integrity and difference, right? And he was fantastic in his job. So he was one person I will never forget. And Sudarshan, my other colleagues in ISRO, they are all very important parts of one's life at that time, yeah. So we had a very close-knit, very, very capable group under Professor Dhawan, but that was not ISRO. That was only part of ISRO. Dr. Brahmprakash, who headed the Trivandrum Center, in my opinion, was not only in one sense even ahead of Professor Dhawan, he was the saint, I would argue. And he was actually the unifying force that made SLV3 possible. Because VSSC is talented, capable, but it's also political, very political. And Dr. BP was the person who's what I call the way he lived and the way he did things kind of united and brought together these diverse, very different political entities within the heart of ISRO's technology capability. And I would argue that he made SLV possible. Now, this is also one of the few times I know in Indian organizations, especially government organizations, I don't know whether to say Professor Dhawan was number one and Dr. BP was number two. I don't see that as that. I think they were both equal. In a sense, I would argue that Dr. BP was even a little bit ahead of Professor Dhawan in terms of his own stature. And nobody talks about Dr. BP anyway. That's one of the sad things that we have. So this was one of those rare occasions where these two people really worked, in tandem and made all this technology that ISRO created possible. And I would argue that this was one of the, I have never known the number one and number two or the number two and one and two either way to work so well together. I have not seen it after that. I have not seen it in any other government entity. I think it was one of those very unique things that made ISRO what it is today. So that is one part. The other thing I would like to take as other talent that we're talking about. Professor Yashpal was the director of the Space Application Center. Everybody knows him, right? He was also, in my opinion, the only person whom I know who was unanimously elected by a very political body called the United Nations Committee on the Peaceful Use of Outer Space to become the Secretary General of the Second United Nations Conference. It was an honor to India, and it simply honored the fact that Professor Yashpal represented, in my opinion, what they thought was the best in Indian science and technology, right? He was my guru at the UN, and he taught me and Rajan a lot of things that we all learned from him. So he is one person I will always, I remember we used to have dinner together and Professor Yashpal taught me how to cook. Okay. So we had this kitchenette in our small room in one of the hotels in New York. And Professor Yashpal told me how to make I still am vegetarian. So he said, if you are vegetarian, you're even more problem. So you better learn how to cook. So he actually taught me how to cook. I think Professor Rao and I, when we used to go together, we kind of continued the tradition. Professor Rao is also a pretty good cook. And we used to have these debates about who's better and all that. But it is very much there. So he is... So Professor Yashpal, Professor Rao also in his own way, was a builder of the satellite center. There's no doubt about that. And then Mr. Seshan, I must say that he was possibly very, very competent, extremely knowledgeable, liked power and the exercise of power. But beneath it, a very good human being because, the few times you've had some personal issues and you've gone to him, although we used to argue and debate about everything and we would never agree on anything in the formal meetings, he was absolutely a great person in terms of how he dealt with all of us. And, I think ISRO does owe him quite a bit, okay. Dr. Kalam, I don't have to talk about. He saw SLV3 and SLV3 was possibly the most complicated project India had undertaken at that time. And a lot of it was possible because of the Brahm Prakash, Abdul Kalam, Satish Dhawan. I would say Satish Dhawan third, but important. They were the three people who actually made it happen. So that is something that you talk about. I would also like to talk about Dr. Govarika's group that pioneered a lot of the propellants and all the stuff that they made, ammonium perchlorate, all the materials that we needed for that were done by them. I talked about Vedachalam and his contribution. Dr. Kasturi Rangan, the project director of IRS, very close friend and another great person. Who all of them became successful in different parts of the space program. So I would argue that one of the things that you remember are all these bonds of experience, friendship, and all that, which kind of even now kind of keep us, even though we are all in the declining part of our life, kind of keeps us going. So that was, I would argue that this was, the period I spent is like this Shangri-La place, right, where I think you suspend disbelief. You believe that anything can be done. And I mean, the demonstration of a lot of it was that. So you had what I call, Professor Yashpal called it suspension of disbelief or something like that. All right. So my point is that was the ISRO of that time, right? And I have another couple of things to talk about, but I thought I will reserve them. I don't know, time? Okay. So maybe I'll talk a little bit about two other things that I think you need to do. This is the time. This has to do with two things. One is what I call the cryogenic story, right, and what happened in the cryogenic thing. And the other one is about my colleague Nambi Narayan and what happened to him, right. These are not necessarily these are not necessarily the great stories that one wants to hear, but it also represents the kind of things that have changed over the time that I was there. Now, one of the things that was a major trigger for ISRO is how do we get to GSLV, right? Now, if you look at the configuration of a GSLV, it depends upon the mass of the communication satellite that you have to put in orbit. Now, this is like a dynamic target. When you look at the progress of the communication satellites, every generation of satellite requires more and more weight. Okay, so if you have to design a launcher to put that satellite in orbit, you got to anticipate what the weight is going to be in the future, and you have to design for that. You also have to be realistic in your timing, because if the launch vehicle gets delayed, you may not have an adequate capacity to be able to put a payload that is meaningful. Now, this was a real problem in the way we had to look at Insat. When Professor Dhawan had kind of decided to quit ISRO and resign, take retirement from ISRO, he had come up with the idea that we would use the modules of PSLV, which we had already developed, and put on top of it a single cryogenic stage, which he believed should be developed in the country, and which would give us the required payload to put into geostationary orbit. And that was the configuration. He believed that ISRO would not capable of doing parallel things, that one focused project and one approach to doing it would be the right way to go. So this was what he kind of wanted. When Professor Dhawan left, ISRO wanted to take another look at all this. So we went through another series of studies, and we finally came up with the possibility that there were other ways of doing it. So one way which many people suggested at that time was we buy the cryogenic stage. Okay. And so that way we would save a lot of development time, because cryogenic technology is difficult, it takes time, and it's hard. It's not easy to do that. So the view was that we would explore the possibility that we could go and buy it. So we spent a lot of time. So we went to the US. They have a stage, Centaur stage, which could do the job. We went to Japan. They have another stage which could do the job. I think we went to the French and the Ariane, and they could do the job. So we spent a couple of years trying to figure out whether these things were going to come up or not. I think the Americans said we'll take a look, but finally said no. The Japanese said no, a big no. I think the French said we will give it to you, but the price was $2 billion and all kinds of restrictions. So we couldn't afford it at that time. That was no. So we had to go back and do an indigenous development. So all this happened, and we went and actually cleared a project with an indigenous cryo, and the government had actually approved the project. Now, when this was happening, the Russians at that time, the Soviet Union had collapsed or on the verge of collapse. The Russians came up with this offer, right, of saying that we will give you a cryogenic stage, okay, which you can use for. And they made us a very good offer, 200 crores or some number like that. They would give you this stage that we could put on the modules of PSLV in our own way and be able to launch it, right? So it was a very good offer, and the Russian technology was pretty good, no question about all that. The only question that was a major issue was what would happen in terms of geopolitics, okay? Now, you must remember there is something called the Missile Technology Control Regime, right? So, the American view was that any rocket stage that could put a certain amount of mass into a certain kind of orbit would be very important, okay? So, they had put a kind of limit, and the cryogenic stage that we were buying clearly came under that. Now, one of the things that went on in debate, and I was actually involved in it, was I said we should have a contingency option. We should have an indigenous alternative, even if we decide to do that. And the consensus in ISRO was that it was not what they wanted. So there was a lot of debate, and we finally went and signed the Russian deal. Okay. And one of the reasons why I left ISRO was also because at that time I had to get out of all this because, all this happened. Now, I had actually made a prediction saying that this is going to backfire, because the Americans and the Russians had a huge space arrangement going, which was worth a couple of $1 billion, including all kinds of stuff that the Americans were just buying out of the erstwhile Soviet Union. Okay, so I think precisely about a year later, the Russians went back on the deal, and then we had to go through this complicated loop of doing not only the Russian engine and the stage. We also had to reverse engineer it, Indian engine, and then we had to develop a new stage. So in a sense, you can argue that all the delays in the realization of the JSLV had to do with this kind of thing. I don't want to go too much into the details. There's a lot of geopolitics involved, but it's again an example of how geopolitics can actually directly affect many, many things. So this is one part. And the last thing I'd like to talk about is what happened to my colleague Nambi Narayan. Okay, now. And this is again an example. This is after Professor Dhawan had left. Okay. Now, my colleague Nambi was accused of being a spy, right? And he was he was taken into custody and beaten up. And then finally, the CBI was ordered to inquire. The CBI found him, not only didn't find him guilty, but they said there's absolutely no evidence behind the charge. And he was released. Okay. Then the government, the Kerala government decided that they would pursue the case further, right? And so they actually started, so the whole process could have repeated. And so this was the problem. I had gone to see him. I'd gone to ISRO to see Professor Dhawan, and I happened to meet him, okay, at that time. And so I spent a couple of hours or maybe the whole day with him, and I felt that it was something terrible, and he was actually innocent, and that we needed to do something about it. Now, obviously, I have no, what I call representative. I'm not an icon. Neither do I have what I call the political recognition that these things can actually. So I mean, like I did with everything, I went and met Professor Dhawan, and I spoke to him about it. And he said, Chandra, are you sure about everything? And all, in his standard style. So I said, sir, I told him, sir, I think what is happening is correct. He said, Chandra, that's not enough. I want to see everything. So why don't you put together a dossier for me and all that? So I and a couple of others who were very convinced about what had happened, we actually put a lot of effort, looked at all the data, looked at the CBI report, looked at the investigation, looked at all the paper clippings and what was being talked about, and we provided a dossier. Okay. And I mean, to convince Professor Dhawan about all this is kind of difficult. But I mean, I must take the fact that he saw that there was a very human-related element that had to be thought about. So after all that, he was finally convinced. And then he said, we will do one thing, he said. So he said, we will put out an open letter, right? Looking at all the evidence, putting everything together, and then trying to say something about it. And he said, but before we do that and go public, he said, let me talk to somebody. He used to know this Chief Justice of the court in Kerala. I don't remember his name, but he was a personal friend of his. Krishna Iyer, Justice Krishna Iyer. He said, I will send the papers to him and let him take a look at it and we'll see. Because he felt that maybe talking to the government in Kerala, talking to the government in Delhi, maybe, can be made to disappear and all that. So I don't know what he had in mind. So we did send that out to them, but we didn't hear anything. So I think finally after another couple of months, we decided that we would go public. And so we actually got, because of Professor Dhawan taking the initiative, we got all the major people who were involved in ISRO to sign on that petition. Okay, Professor Yashpal signed, Professor Rao signed, Mr. Seshan signed, and then Professor Narasimha was a member of the Space Commission and also very closely associated with Professor Dhawan signed. And I signed because Professor Dhawan said, since you did all this paid work, you should also sign. So we actually signed that petition and we put it out into and meanwhile the Supreme Court had heard it and it became what is called sub judice. So I think Professor Narasimha went and consulted Justice Venkatachalaya and I think he said we should not do it and all that. So I think we again had this debate and then finally Professor Dhawan said it doesn't matter. I think we have to do it and we finally went and did it. I don't know whether it had any impact or not, but according to Nambi, who was directly involved in it, the Supreme Court finally, came out in his favor. He was awarded damages and then he pursued it for a long time and now more or less everything is settled. I think there's a film now being made upon it. I don't know how much the film will actually reflect all this reality, but it was quite a messy affair. And, it represents this very unique combination of politics and internal differences and all kinds of politics. It's like, this alignment of planets that people talk in astrology, which I don't believe. It seems to be a real life example where all these, happened and this guy, poor guy, had to face the consequences. So that's the other thing that I thought I should kind of share with you, right? See, when I joined ISRO, I had two ambitions, okay? One was, I didn't believe I was going to live in India, okay? I mean, very clear. I had two ambitions. I actually majored in finance, economics, and marketing in IMC. I'd kind of lost this belief in technology. I studied in IIT, fancy place, all that. I didn't get a job. Okay, so I said, what the hell? Why should I go? And so one thing in business is that you figure out, what is important, and money is obviously important. And economics and finance sounded to me, and marketing sounded to me to be a great job opportunity. So I actually had this interview with the Tata Administrative Service. Okay, I mean, I don't know how they called me, but they called me. And that interview I didn't do. I mean, I didn't make it to the final round. So I was thinking of a Tata job or a job in a bank or something like that. And, the ambitions of management guys are all, very money-minded. I was no different. I don't think I was very fundamentally different. And then ISRO came to campus and they made me an offer. Now, the reason I decided to take it seriously was my younger sister was at the Institute of Science doing a doctorate. My elder sister had just gotten married and was moving to Bangalore. And my mother historically grew up in Bangalore and she's a Bangalore girl. So I said I should therefore look at it and I came to ISRO. My priorities were very clear. I said I'm going to spend maximum 2 years. I'm going to learn a little bit and I'm going to join, do a lot of work on economics and join the World Bank. So these were my two main goals at that time. So when I joined ISRO, maybe the first few months I was not particularly doing anything great. I mean, it was like, a kind of initial experience of feeling it out and all that. So my first job was to manage the ISRO budget, since I come with a management background and all that. So we pioneered something that Professor Dhawan pioneered, something called program planning and budgeting. It's the first time in the country that we actually do what is called link money to programs. And ISRO has this masterly transformation, I don't know whether they still have it, where you take the program-related elements which make sense from a technology, a government accounting which is horrible, okay. So you have to be able to convert from one form to the other, and we kind of pioneered a lot of it. So we started this program planning group and the systems programming analysis group. So my first job was to control the ISRO budget, which I think when I first joined, it was 15 crores or something like that. And I was responsible for managing. We used to look at every 1,000 rupees, 10,000 rupees and all that in those days because we were broke, really broke. And it was also a very powerful job because, everybody who mattered in ISRO had to come to you because you were in charge of the money. I remember Dr. Kalam used to come, right? So you actually had this fairly powerful position, even though in the hierarchy I was possibly the lowest down in the hierarchy, right? So that was how it was. So what happened is I suddenly became particularly fascinated by the possibilities of space. And initially, I was looking largely at, the vacuum in ISRO at that time was remote sensing because Rajan and I were the only two people looking at it. And so I decided that I would kind of learn a little bit about looking at. So we did a number of aerial surveys. I was involved in a lot of that. And I got involved, and Bhaskara I got involved. And IRS, I did a lot of the spade work, and I got hooked. Okay. And the problem was Professor Dhawan saw this contradiction in me. He was not sure I was going to stay. So he and Rajan, my boss, actually I don't remember the date, but I think early on, they decided that I would be sent out of the country. They wanted me to get exposed to the world. So they sent me on a kind of visit to California. Okay. There was this remote sensing workshop that NASA was holding. And I was nominated to go and attend that workshop. And Wing Commander Rao, who was the head of NRSA at that time, was also there at that workshop with me. So I got to know him also very well. Another great Indian whom nobody talked very much about. So I worked there. I went there. And, they also made me visit. I had a 6-week visit. Okay. I went to all the scientific establishments and the NASA centers in the whole of California. So from San Diego, which is on the southern thing, all the way up to San Francisco and all that. And, I had a number of classmates from IIT who were working in Stanford. For example, I had a classmate in Stanford. They were all working on integrated circuits, for IBM, for Intel and all those companies that had started at that time. And I came back very excited, saying there's a lot of possibilities. That trip made me realize that the kind of job that I was doing in ISRO was far more interesting in terms of challenges than what one would be able to do in the US. So in a sense, it kind of transformed me from this outward-looking, foreign guy. I think it's a mistake, frankly, if I look at it. But it happened, okay? And I think it had largely to do with ISRO culture and Professor Dhawan and his personal kind of impact that he had on all of us. Not only me, on all of us, Sudarshan and also me. So this is the point that, so I kind of changed, okay. And I think ISRO, so I remember Professor Dhawan sent me to the UN to represent India when I was 26. So I was speaking on behalf of the country on all kinds of matters of policy. Of course, you go through this process of consultation. So I at one stage in India, I was possibly the only guy on the legal regime of space. I used to know more than anybody else at that time. And we all negotiated much of these treaties. So all of us still are, in a sense, I'm still very comfortable with all the space laws, treaties, etc., even though I haven't done much in these areas now, but it is there. So you had all these kinds of things that happened. So that was something that, I have always, even now, I think space is something that is really kind of, I'm in love with. I also hate it at times when when you don't get what you think you should get. But I kind of love it, and it's something that I don't know. When I look at these pictures from Jupiter that NASA sent and all that, it's awesome what it can do, right? Not only all the economic stuff and all that, but look at it in terms of knowledge. Look at it in terms of doing a lot of other things and knowing about the world and knowing all that. So I kind of, spent wasted a lot of my life on doing this part. So I know a lot about it, but my point is, I don't think it matters very much what you know. But the final analysis, I moved to IIM, right, from ISRO. I think IIM was very good to me. I did a lot of work on technology, which I had not done in ISRO. But a lot of that ISRO experience and the way to look at the world and the way to understand the world. And if you teach, the theory gets grounded in practice. So my understanding of how ISRO worked and how ISRO can be made to work and the organizational parts which are all there. And it's it's a very, what shall we say, fulfilling kind of thing. So I have a number of cases. I've written a lot on, I have cases on space. I have some cases on the Columbia accident and how NASA does, how ISRO does. So all the stuff that can connect technology with business, crisis, management, leadership, those softer parts are quite there. So for me, it's been a very, the ISRO experience and what I learned there has been a building block of everything that I've done. And as I said, it's the Shangri-La of one's life. Okay, I don't know whether I can ever get back to it. No other organization for that period gives you that satisfaction. And I would say that ISRO and my colleagues, all of them who are so generous with what they knew and gave and parted with. It was, as I said, a great place.